Okay, today we're going to continue on section 8.3, trigonometry integrals. Trigonometry integrals. Okay. First, let's look at two kind of trigonometry integral forms: sine x power m and cosine x power n dx. Okay, and secant x power m and tangent x power n dx. Okay, sine, cosine, and m and n can be any number. M and n can be any integer. Okay, so we have these two forms, which is very usual for the trigonometry integrals. Okay, right. So first type of question is, if the power of sine is odd and positive. Okay, save one sine and convert the remaining factors to cosine. I should have just give you example, and then let you guess what we are supposed to do, and let you think about it. Okay, for example, I just give you example first. Sine x cubed cosine x squared dx. Okay, so here, what do you think I can do? So we have sine and a cosine. Okay. What we can do is, I'm going to change something. You can see why I do that. Okay. So I can change the sine x as a cube. Square is much better. Why is square much better? Because you can use reduced power formula. Cosine x squared equals half of 1 plus cosine 2x. You can use reduced power formula to reduce the square formula. Okay, but the problem is the cube. The cube is not good. So what I can do is I can break the cube into a square, and an extra sine x dx here is multiplication. So sine square and sine x together, multiplication still give you x sine x cubed. However, sine x dx, I can change this one into d of, you can change this into d of cosine x with the negative sign, because derivative cosine equals sine. Does it make sense? Sorry, derivative cosine equals negative sine. Yeah, that's right. Okay. So here, what you can do is, you can break this odd power into another additional sign, put one sine x here, and use that as d of cosine x negative. Okay. You can see that, right? Now, the problem is, well, I have this is a cosine, this is a cosine, and this is sine square. Can anyone tell me what I can do next? What do you think I can do? Because this is cosine square, this is cosine. If this is cosine, that will be much better. Excuse me, right? Okay. So, Lacey, what do you think I can do here? This is cosine, this is cosine. If I do u substitution, well, I can do u square here, right? I can do a du here. But what about this one? 之间 or anyone? Matthew? What do you think? Taylor?
Do we have a trig identity we can substitute in there?
That's perfect. Yes, we can use the trig identity sine x squared plus cosine x squared equals 1. Then the sine will be replaced by 1 minus cosine. Right? Okay. So basically, I can substitute the sine x squared into 1 minus cosine x squared, and then cosine x squared, and d of negative cosine. Well, the negative doesn't matter. You can take it out as a negative coefficient. Then everything is perfect. You can distribute that as cosine x squared. And distribute that is minus cosine x power 4. And then you have d of cosine x, and you have a negative here. You can put negative right in front of that. Well, then, since d of cosine this is, you can use u substitution. Everything's u. Sorry, everything is u. Okay. You can do u substitution here is u squared, u fourth, du. Okay. You don't have to change that. Normally, I would just do negative cosine x power 3 over 3 plus cosine x power 5 over 5 plus c. Then we're done here. Okay. You can continue, you can do u substitution. It really does not change anything. U equals cosine x, and you have negative u squared minus u4 du. And then you have negative u cubed over 3 minus u5 plus u over 5 over 5 plus c. Then you plug u back into that is minus cosine x power 3 over 3 plus cosine x power 5 over 5 plus c. Okay, this is if you use the u substitution, you got exactly the same thing. Okay, but if you have something like this, you don't. If you are familiar with this with this integration, you don't have to change anything. Okay. Does that make sense, everyone? Great. Okay. So this is what we do for the sine power, which is odd number. Okay. So next one, what if the power of cosine is odd? If the power of a cosine is odd and a positive, what do we do? For example, you can do sine x power 4 and cosine x power cube and dx. If we have something like this, I'll give you 1 minute to do this one by yourself. Okay, I think if you're done, you should be almost done. Yeah. So what we do is sine x power 4. We can break the odd power into cosine x squared, the same thing, and another cosine x dx here. Okay. So cosine x dx, we can change that into d of sine x. We can do the exactly same thing. Then we have sine x power 4. Well, cosine x and sine x, this is sine x power 4, this is sine x, this is cosine x squared. We use that again, sine x squared of d over sine x. Okay, and then you have this is sine x power 4 minus distributed minus sine x power 6 and d of sine x. Okay, then you can use u substitution if you would like to, but normally I would just do sine x because you have this exactly the same thing. So you'll just have sine x power 5 over 5 minus sine x over 7 plus c. Okay, did you all get the same thing? Does it make sense?
Yeah.
Okay. All right, so you do exactly the same thing. Well, let me just finish. I'll give you, I think you can finish that by yourself if you don't have it. So if it's odd and positive, we do the same thing. And if it's odd and positive, and we save one cosine factor and convert the remaining factors to sine. Okay, I think it is very organized. Okay, this is either one. Sine is odd, cosine is even, cosine is odd, sine is even. What if there's another case? What if they're both even? If the power of both sine and cosine are even, if the power of both sine and cosine are even and positive. For example, what if I have sine x squared cosine x squared? What if I have a function like this? Now we can't change that because if you do, if we have both even, I cannot take one aside because if I take one, then you have an odd number coming out. Okay, so if it's like this case, if both are even, we're going to use the power reduced formula. Okay, use power reduced formula. The power reduced formula is sine x squared equals half of. Can anyone tell me what is the sine x squared equals half of what? One. Cosine 2. Okay, continue.
Sine minus cosine 2 theta over 2.
That's right. So sine x squared is, thank you, Lacey, 1 minus cosine 2x over 2. At the same time, I also have cosine x squared equals half of 1 plus cosine 2x. Okay. If it's this one, first, I would not do sine, cosine, and then this minus this. Because this will give you another square. So we know there's another formula. 2 sine x cosine x equals 2 sine x cosine x equals sine what? Sine 2x. Okay. Sine 2x equals 2 sine x cosine x. Okay, so now if I can combine these two, you can do that. You can directly reduce the formula this one here. You can reduce the formula this one here, but you're going to have another square again. And you have to use the reduced power formula again. So instead of doing that, well, that's not hard. Eventually you can get it for sure. Okay, if you use reduced formula here, once you get a reduced formula here, for sure you can finish it and without any problem. Since I know that sine x and cosine x, you can get sine 2x, well, then I just combine these two together first. Sine x cosine x squared dx. Well, sine x cosine x equals, you can divide both sides by half. You divide this by half, you can take out the 2 and you put 2 here. So you got half of sine 2x squared dx. Well, 2 squared is 2, so you can take it out, it's 1 over 4. 2 squared is 4, so you can take out 1 over 4 its coefficient. You don't have to worry about that. So I have 2 sine 2x squared. Now then I use the power reduced formula. I just have to use the power reduced formula here once. Since sine x squared equals half of 1 minus cosine 2x. Well, now I would someone to tell me if I do the power reduced formula here, what would it be? What would it be? Can anyone tell me what would it be here? I'm going to say, let's see. Eric, could you please tell me what would it be here if I use power reduced formula?
2 minus cosine 4x over 2.
Okay, the formula is sine x squared equals half of 1 minus cosine 2x. So the 2x is pretty much like a theta here. Well, I can change this into theta. You don't get confused, right? It's theta and 2 theta. So now what do you think? The 2x together, the theta.
It's 1 minus cosine 4x.
Very good. It's 1 minus cosine 4x over 2 and dx. Okay. So then we don't have any power. We just have a simple trigonometry function here. This is the constant. I don't have to worry about the constant. It's just a half minus 2 cosine 4x dx. Right? And this is a constant. This is just a simple trig function. You can do the antiderivative. Now, I would like to someone can tell me what would it be here. Continue. Can anyone tell me the final result? Let me say, maybe Jasper, can you tell me?
So it's 1/4 times 1/2 x minus sine of 4x over 8.
Perfect. Very good. Okay. So thank you, Jasper. So 1/4. When you do the 1/4, you keep that, and you have a parenthesis, and make sure this is together, and a 1/2. It gives you 1/2 x. Cosine 4x is sine 4x over 8 plus c. Okay. So this whole formula, there's this trigonometry integral. The trick part is that you use the power reduced formula once, and also the half integral, double angle formula. Okay. So that's the whole part after this, after you use the reduced power reduced formula, everything's quite much simpler. Okay, this is how you do if both are even. And then let's look at a formula. It's called a wireless formula. Okay, if n is odd and n bigger than or equal to 3, because if n is just 1, you can just take it, do it very simply. Okay, so if the n is bigger than or equal to 3, 0 to pi over 2, and cosine x power n dx equals 2 over 3 times 4 over 5 times continue multiplied by n minus 1 over n. Okay, and even if n is even and n is bigger than or equal than 2, then if you have 0 pi over 2 and cosine x power n dx equals half times 3 over 4 times it's all 5 over 6 multiplied by n. Question? Lacey? Okay, I think because that is m minus 1 pi over 2. This is just a formula in the if it's going to be the same for sine x. Okay, same for sine x. Okay, this is just two formulas of 0 to pi over 2. Cosine nx dx is 3/2 2/3 times 4 over 5 times n over n minus 1 over n. Okay, if it's bigger than 1. And we can look at this example. Look at example. If we have 0 to pi over 2 and cosine x power 7 dx, if we use the formula, it's going to be 2 over 3, all the odd numbers, 4 over 5 times 7, 6 over 7. So basically you have, this is power 7. You start from 3, 3, 5, 7. Okay, let me see. Okay, then I would suggest you go back and try to prove this one. Once you prove one of them, it will be enough. I want you to prove that one today at home. Prove this formula as an exercise yourself, not homework. But I want you to try it. See if you can prove that. Or maybe next class after you try it, I will show you the whole proof, how you get the whole formula here. Okay. So today we just look at how to apply those two formulas first. But I would like you to go back and try to prove this one of this, because if you prove one, the other one is very similar. Alright, so what if I have 0 to power over 2 and they have a cosine x power 9 dx? Well, then this will be 3, 5, 7, 9. So it's 2 over 3 times 4 over 5 times 7, 6 over 7 times 8 over 9. This is pretty simple. Once you know the formula, the whole process is very, very similar. Very, very easy. Okay?
I have a question.
Yes?
Does this only work when you're going from 0 to pi over 2?
Yes. That's right. It's only work from 0 pi over 2. That's right. That's a formula given in the textbook, and also it has the exercise to prove in the end. We can look at that. I would like you to try to prove yourself. It's only from 0 pi over 2. Yes, you're right. Okay, so let's continue to do more exercise. Okay, do more exercise.
I have a question.
Yes.
Yes?
If we have a question like cosine x cubed dx, do we have to like reduce that too?
Like that.
And that?
Yeah.
Cosine x, just cosine x cubed. Let me think. Reduce the power reduced formula. I think this one I would do. Take one as cosine x squared here, and you put one aside because the odd number, and the cosine x dx, right? And then you will have cosine x squared, and this will give you d of sine x, and that's not a big problem for me because I can change the cosine x into 1 minus sine x squared. D of sine x. Make sense? Yes? Okay. But you do have more work. It's not that simple because this one is not a u here. Okay, if you do u substitution, it's not really working here. If you do u substitution, u equals sine x, that is not u. They have to do some work here. But this is how will I do this. Does it make sense? Yes, Lacey? Okay. Alright, so let's look at another example. What if you have x sine x squared dx? In the previous class, I think did something about x sine x sine x e to power x use integral parts. Here you have a multiplication. Here is sine x times sine x. So I'll give some hint. You have to do integral parts. Okay. Integral parts. And also, probably not. Let me see if I need. Yes, you need to integral parts and also power reduced formula. I'll give you this one to practice. Please practice this one. Give you 2 minutes practice if you can finish it. First the power reduced formula, then integral by parts. Okay, I think most of you are done. So here, use power reduced formula. You get x times. I would like anyone. Oh, this one I would just finish that because when I look at it, it's pretty simple actually. So after Lacey, your question here, cosine x cubed, you do this until here. So even you have d of sine x, this is 1. You just take the antiderivative of that, is just sine x. Minus, this is sine x squared, so it's sine x cubed over 3 plus c. Okay, that's how to do that. Or if you use the u substitution, it does not really, if you do u equals sine x, the whole thing will be just the 1 minus u squared and du. And the answer is u minus u cubed of 3 plus c. Then you put u back as sine x, so it's sine x minus sine x cubed over 3 plus c. You will have exactly the same answer, okay? That's how you do that cosine x cubed. Sine x cubed, it will be the same thing. You put 1 sine x aside and use that as a derivative. Change that sign to 1 minus cosine x squared. You will do exactly the same procedure for sine x cubed. Now for this one, sine x squared, use power reduced formula, is half of 1 minus cosine 2x dx. Alright, so let me think. Alright, so I would like to ask a student to help me continue here. Is there any student I've never caught before? Matthew, let me see. Jasper there. I have to go back check the name again. Luke, can you help me with this one? Continue here.
Then you can distribute in the x.
Okay, distribute the x, so it's x over 2. Then minus x
Minus x cosine 2x over 2.
Very perfect. Good, great. So can we continue?
And then you can just integrate x over 2 on its own.
Okay.
And then you take x as the u and cosine 2x as dv.
That's perfect. U dv and cosine 2x. And then
the derivative of x is just 1. Integral of cosine 2x is just sine 2x over 2.
perfect.
And the next integral is negative cosine 2x over 4.
Oh, so we continue this one as well, right? You need a 0 here, right?
Yeah.
Okay.
Yep, 0.
And this one is cosine, negative cosine 2x over 4. That's right. Perfect. So then we do that plus, minus, plus, right? The tabular method. Okay, so could you please continue?
And so then you have just x squared over 4
Very good.
minus x sine 2x divided by 4
Divided by 4. Very good, yes.
plus cosine 2x divided by 8.
Plus cosine 2x. That's perfect. Very good. Thank you very much, Luke. Okay. Oh. That's perfect. Okay. So in this problem we have used the power reduced formula and the integral by parts tabular method here. Combine both methods together. Okay, which is a very good problem for you to practice. Okay, very good example as well. So what if I have something as, next example, what if I have something as this, sine 3x cosine 2x dx. Well, that's a big problem for me here because, well, this is sine 3x, this is cosine 2x, they're not the same theta. One is alpha, another one is beta, it's totally different. I cannot combine those two as use any half formula or what. But we do have a formula to combine these two functions. Does anyone still remember that sine alpha cosine beta equals what? It's half of sine alpha plus beta plus, wait, am I doing it right? Just give you a maybe longer way to write it. Okay. So sine alpha cosine beta equals half of, okay, sine cosine is sine plus sine. Okay, so sine half of sine alpha plus beta plus sine alpha minus beta. This is a trigonometry you should have learned this formula. Okay. Sine cosine sine plus sine. Okay, cosine sine is sine minus sine. So cosine, I'll just write everything here. Cosine alpha sine beta cosine sine equals half of cosine and sine is the same thing, right? Sine cosine can switch, it's cosine sine. Okay, sine cosine is that, and then we have sine sine, where sine alpha sine beta equals half of cosine. I should switch those two, but you don't forget it. Cosine alpha minus beta minus cosine alpha plus beta. Okay, and then cosine alpha cosine beta equals half of cosine alpha minus beta plus cosine alpha plus beta. Okay, these are the three formulas. My bad. These are the three formulas from the trigonometry. Okay, and you can apply it to here, for this problem here. If we have sine, cosine, then we just use the first formula. I will ask the student to help me here. Zijian, could you please help me continue? So sine 3x cosine 2x equals what? Can you press that button? Yeah. Number 2. Which is 5x plus which is x. Very good. Okay, thank you very much. Could you please continue? So half is a coefficient, you can just take it out. So half sine 5x plus sine x dx. Can you continue finish this? Derivative of sine, integral of sine 5x would be negative cosine 5x over 5. Very good, perfect. Next one. Negative. Very perfect. Okay. So, thank you very much, Zijian. Then we have half of sine alpha plus beta, just 3x. So we have 3x plus 2x is 5x plus sine 3x minus 2x, which is sine x and dx. Then this is just a simple trigonometry and derivative. So half of sine 5x is negative cosine over 5. Don't forget the 5 over here. Okay. So this is another form which we have. You can do this way. And this is sine and a cosine. In the book, you will have a more example. I almost covered everything of sine and cosine in the textbook. I think tomorrow I'm going to cover, not tomorrow, next time, which is Monday, I'm going to cover the tangent and cotangent. Well, in the homework, let me think. The homework do we have? You might have some tangent and cotangent, tangent and secant as well. Okay, but you'll just try your best to finish as much as you can. I probably will extend that homework one more day for the tangent and secant part. We have not covered it yet, right? Next Monday we cannot cover that part. But tomorrow we are going to do the test review. Please bring me any questions. And